teach you, so that's awesome that you don't know something.
Rheological properties of liquid is the physical properties that result in deformation or flow of liquids in the presence of stress. That means whenever a force is acted on a liquid, say a liquid or a gas, it changes its shape.
Okay, so does anyone know some of these properties? What are properties of liquids? Any guess? We're not going to pitch you. No definite shape, so that's what we're getting for. What's the liquid?
Definite
Volume. Okay, so what the properties are we're going to be focusing on are viscosity. So, anyone know what viscosity is? Okay, well we're going to discover what it is.
Viscosity is the resistance to flow in a liquid.
What factors do you think affect viscosity? Does anyone know? Any guesses? Air and water? Any more guesses?
How big it is?
Right.
Maybe a
Right,
Yes,
exactly.
that's very good.
Well, it's like when you're like water rafting, like there's a rock and it's resistant.
Yeah, yeah.
It's mass.
Mass.
Okay, so here's some properties.
So viscosity is affected by several things, some of which are substance, so what it's made of. Temperature, like how hot or cold it is, depends on how fast it's going to resist flowing down the stream of water. The time and the pressure that's applied to the liquid.
So here we have ketchup and honey, and on the right we have water. What would y'all think has the highest viscosity?
Honey.
Yeah, that's right.
And
And
that's the second highest.
All you guess.
yeah, that's true.
Yeah.
And water has low viscosity because it's easier to flow.
So like I was saying earlier, there are different types of liquids. We have fluids. There are liquids and gas. And we're going to be focusing on liquids and the properties of liquid.
Newtonian fluid is viscosity is only affected by its temperature. And can y'all think of any scientists who would have come up with that?
What's the guy who's saying his last name is Newton?
Yeah.
Isaac Newton.
Isaac Newton, yeah, that's the name. Well, later scientists discovered that there are other types of fluids that are affected by temperature and pressure, so these are called non-Newtonian fluids. We're going to discuss the differences today.
So what we're going to talk about in relation to viscosity is what is surface tension. Who can tell me?
Is that like where you're pouring your water in the cup and then it sort of like makes a bubble on top?
Yeah.
You are exactly correct. Those bubbles, the molecules on the surface, are sticking together, so they're making the surface tense and forming that bubble. So those are called cohesive forces. The molecules are cohesive. So how this affects viscosity is that if you have a higher surface tension in the molecules, they're going to have stronger forces and they're going to want to stick together. So the viscosity is going to be higher because those molecules sticking together aren't going to want to flow too well.
What about carbonation?
Okay, carbonation would be adding like a gas that would be changing its substance. So that would make it easier to flow because carbonation is just like adding carbon dioxide, which is a gas. So it's going to have an easier flow.
Good question. These are some examples of surface tension. So when you're riding in the car and it's raining and the water molecules are sticking to the window, that's because of surface tension. And also, you can see down there in the corner that bug is walking on water because of the surface tension of the water. It's not falling into the water. And then paperclips can float on water too. We're going to do an experiment on that.
Alright, wear your goggles at all times. We're about to split up into stations. Before you go, we're going to number you off. So just start counting. We're going to start over here, say 1, 2, 3, 4, and just keep going around the room. So remember your numbers.
They can do it. They'll do it if you start them off. Start
Okay.
with you, Noah. 1.
2, 3, 4.
Ethan.
8. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2.
Good job.
Alright,
Okay, y'all can do it.
So we have 4 stations, so it's perfect. Y'all are counted off into 4s. So I need all the ones to go with me. We're going to be at the end of this table.
Stand and walk.
No one move yet. We're going to tell you all where to go. So ones are going to be with me back there.
Jenny, where do you want 2s and 3s?
Twos are there.
They're right here at the end of this table, and then 3s are going to be right down here with me.
Okay, 4s are going to be right over here
Over
with me.
there.
What's station 1?
The resistance to flow. So the harder your resistance,
Okay.
the higher the viscosity.
So we're going to
Place them more. We're going to place them all
Oh,
over the
okay.
jar.
So that would be your.
Fill each jar with something different and it has a different viscosity. Flip them over. See which one
You think they're all the same?
Can't remember what we're doing at
No.
this stage.
Because they're all
So, by that, which one do you think? It's going to be. That's right.
Do you remember what makes
They got to put it right here. Water.
So right here, that's all the other ways.
Right there.
like putting on some water or make it they stick together, right?
And step number 2 is
What makes it do
you
that?
go get the water.
Alright, does everyone have both? Okay.
Your hypothesis.
That's funny.
It's really light surface.
So how many of you think this is a
Okay, now this is
Alright.
Towel.
Today,
right here?
y'all remember what viscosity is?
Yeah.
It's like how the lens affects the liquid gas.
Whatever.
Okay, so it's the resistance to flow in
Make your
liquid.
educated guess.
So if it has a high viscosity, it
Okay.
has a high resistance.
So we're gonna
It
test
means
your
the liquid does not want to flow.
And we're
It
going
moves
to
really slow.
feel it. So right
Okay.
now we have
So today we're going to
7
put
people. We're going to
marbles
split up
in the bottom of
into
these jars.
So
shifts.
We're going to
To
fill
go
them up
wide
with
and
different
then
liquids.
go
Like
back
corn syrup,
or like on that side.
mineral
Or
oil,
can't move down
baby
here.
oil,
can we float on the water?
and vegetable oil.
Hey, you're not
Then flip them over. Every bottle. Then we move them over. And see which one is the bottom.
You can observe right now and see if you can make any
Right.
based on what they do.
Alright, so my hypothesis says split all the resistance to the bottom.
So, ready? 1, 2, 3. You're gonna stick your fingers Watch your fingers in. I need you to make sure you keep your fingers over the container and don't spill it like I.
Okay.
So try to stir it. Hurry. Y'all are on the second
So,
Okay, so now try to stir it faster. Alright, okay. What do you observe? True. Can you stir it really slowly?
put a marble in the bottom of
Okay,
it.
with 33.
If you take both hands
Put a
out,
marble in.
Okay, what do you got? 35.
Okay. Now you fill. That's not corn syrup.
Okay.
try to stay 30. Try to stick. Jeremy's desk is one. Try it. Hold on.
Okay, now we're gonna add up.
Try to stick one finger in. Slowly. And now stir it real slowly.
35.
Can you stir it real easy? Hold on.
Take some each eyes, okay?
something like that. It's like,
Figure out.
Good job. So,
well,
how,
it's
what
like,
percentage of the paper gets dropped?
no, it was 100%.
Which one's gonna drop faster, low viscosity or high
Something else we talked about.
Hey, y'all just hold on one
What
second
changes
for me,
the
okay?
viscosity?
Okay, we're gonna write our conclusion. So, who needs, go put your paper, your dirty paper clips in
There we go.
Who needs the
Think of that.
paper towel?
No, that's it.
Go back. That's
You gotta wait for all of these to finish. So we don't want to get away with
Okay, go wipe your hands off. Alright, who else needs to
Alright, now we're gonna
Wait,
dump
it's
it
on
out
the bottom.
into the center.
Wait.
I know, it's not gonna work.
It felt like that.
Okay.
I know.
Okay.
Don't rush it. It's like
So we're gonna fill out your
Alright, let's
chart.
go
We're
clean
gonna
up.
use trial point and write the conclusion. So we're gonna fill out y'all's conclusions, okay?
If you have a jar, come over here and dump it out.
Oh yes.
You don't have to stick your hand in to get the marble.
I want to jump all this.
Okay, think about it. Once you
I'm dumping all this corn.